A very warm welcome to everyone joining us today. After the successful completion of the first 3 days of our faculty development program, we now step into the fourth day of this academic journey with renewed enthusiasm and commitment to learning. The past 3 days have offered us valuable insight into diverse areas of sustainability, energy systems, and urban development, delivered by some of the most distinguished experts in the field. Each session has broadened our perspectives and inspired us to think deeply about innovative and sustainable practices. Today, as we begin the fourth day of the FDP, we look forward to yet another series of enlightening lectures and interactive discussions that will further enrich our academic and professional understanding. Moving forward, we are moving to the seventh session of our faculty development program. It is an honor to welcome Professor Joyashree Roy, an eminent economist, researcher, and globally recognized authority in climate change and sustainability. Professor Roy is currently the Distinguished Professor and Founder Director of the Center on South and Southeast Asia Multidisciplinary Applied Research Network on Transforming Societies of Global South at the Asian Institute of Technology, Thailand. She also served as the inaugural Bangabandhu Chairperson from 2018 to 2022 at AIT and earlier as Professor of Economics at Jadavpur University, India. Professor Roy has played a leading role in the IPCC assessment cycles, contributing as coordinating lead author in the fourth, fifth, and sixth reports, and was part of the 2007 Nobel Peace Prize winning IPCC panel. She has published over 190 research papers, authored books, and has been consistently listed among the world's top 2% scientists in energy research. Her pioneering work in climate change modeling, carbon pricing, and sustainable development has earned her several honors, including 2021 Paradigm Award USA and the Prince Sultan bin Aziz Creativity Award in 2012. Her research spans across energy, environmental economics, climate change modeling, carbon pricing, water and resource economics, and sustainable development. She also features in the documentary Juice, How Electricity Explains the World, highlighting the transformative role of energy in development. Let us now warmly welcome Professor Joyashree Roy.
Thank you very much, Shafiq, for your introduction. And so let me start sharing the screen so that it can be visible to all. Just hold on for a minute. From the organizer's point of view, can you mute the other participants? Otherwise, it becomes very disturbing. Okay, so current state.
Ma'am, voice. Ma'am, you are muted.
Good evening, ma'am. Ma'am, your voice is not audible.
Ma'am, please unmute yourself.
Yeah, I hope you can hear now.
Yes,
Yes,
yes.
ma'am.
Okay. All right. Sorry for that. All right. So what I'm going to share with you all is the current status of climate change scenarios. And what I intend to do is mostly based on the latest assessment of scientific understanding based on global assessment reports. And so I'll cover three things: change at the physical system level, and impact and adaptation to such change on human system and ecosystem, and how to mitigate the impact. Of course, I'll share some of our research results on India's response and possibilities. If we look into this figure, what it shows is that human influence has warmed the climate at a rate that is unprecedented in at least last 2000 years. So how do the scientists come to this conclusion? I want to say that in IPCC process, as you know, that thousands of researchers nominated from each country participate, and they scan through all the published literature in the scientific journals and consider all journals, and then do a meta-analysis to understand what scientists globally has to say about climate change. So the last report of IPCC, the sixth assessment report, showed that if we look into this figure A, we in the left-hand side, it shows that how the temperature change has been influencing the climate change. And based on, they have global surface temperature has been reconstructed from paleoclimatic archives, which is this gray line which you see from till 2000. This one has been reconstructed from paleoclimatic archives, and it is representing the change relative to 1815 to 1990, taking a decadal average. And this part, which is the black line, which is from 1850 to 2020, shows the observed change, the observed data. So basically, what it says is that if you look into these past 2000 years, and if you see these 170 years, past 170 years, then you can see that this observed change has surpassed all the past experiences on Earth about the temperature change, right? So even if you go back, say, 100,000 years, that has also been reconstructed, and it has been shown that maximum rise was seen as 1 degree Celsius compared to 1850 to 1900. So basically, this current experience is exceeding any change that has been experienced over 100,000 years, and spatially over 2,000 years, which is very easily seen. Now, the question is, in the first 2,000 years, say, for example, in the past, during the Holocene, whatever change happened was due to the change in the orbital movement of the Earth. And now what we are seeing is the human constructed change. How do you know that? If you look into the right-hand side, then you can see that this blue line and the blue shaded area shows that had there been no human activity, then the solar activity and volcanic activity would have produced this much of temperature change on Earth even during this period of 1850 to 2020. So the observed change is this line, right? So which means that this is due to the human action. So if you consider human and natural actions together, this observed change is showing this natural change and natural and human change. So this gap can be seen as the human activity led temperature change, because many a time it is scientists are arguing that maybe it is because of the solar activity, maybe due to the volcanic activity, these changes are happening. But now scientists have clearly shown that with high confidence that no, it's not explainable by the natural changes only. So human action after the Industrial Revolution has made these changes more. So based on these, this is important that we now know what is the natural impact and what is the human induced impact on temperature. So if the emission of CO2 and the other greenhouse gases increases, so it shows between 1850 to 2100, if these have been estimated and predicted by the different scenarios by the scientists, as I said, it is just not one scientist or IPCC producing, but it is based on meta-analysis of all the scientific papers that gets published. So based on that, what it shows is that so these SSP1, 1.9, these are the different socioeconomic pathways assumed that how the global economic activity might be changing or human activity might be changing. And 1.9 and 2.6, all these are showing the radiative forcing. That means how much of the the energy balance on Earth, you can say, in simple terms, right? So this shows that as we are moving to more warmer world, then what it means is that greenhouse gas emission is going to increase. And as it increases, this 70% is showing naturally how much the land and ocean can absorb this emission. So that means there is a natural process of cleansing. And when it is less emission in the atmosphere of greenhouse gases, then there is more absorption by the land and ocean. But the land and ocean's absorptive capacity reduces as the more and more of emission is done by the human activities. Because in that case, if you see in a very high emission world, what will happen is that land and ocean's capacity for absorption will be very less. So the carbon sink was larger in land and ocean, but this will be absorbing still more. But then with more rising emission, it says that with higher cumulative CO2 emission, the absorptive capacity will be only 38% and rest of it will be remaining in the atmosphere, which will change the energy balance and the warming level on the Earth's surface. So this is extremely important to understand that if we go on emitting more and more and more, so land and ocean will cease to uptake it, which it can take 70% now, but then it will be reducing, its capacity will be reducing, and in the atmosphere, greenhouse gases will be remaining. So with that, what will happen is that it shows that in the physical system, there will be multiple climatic impact drivers which will change in all regions of the world. And what are these multiple climatic impact drivers? So these are categorized under these broad categories: heat and cold, wet and dry, wind, snow and ice, and then coastal and open ocean, and others also, air pollution, matter, etc. So under each, it shows how the surface temperature will be increasing and how, say, for example, cold spell or frost will be decreasing. So these are showing what parameters will be decreasing and what will be increasing. And also what you need to understand is that these colors, the darker the color, it shows how high confidence in the scientific evidences are. That means there are many, many studies are confirming this phenomena or projection. So that's why these colors show where there is less confidence and less studies are available. And this dark color ones shows that science is high confidence for increase in, say, mean surface temperature or extreme heat. So these are very known facts. So atmospheric CO2 at surface level is going to be very high in many of the regions. So if you look into marine heat wave is going to increase, ocean acidity is going to increase, coastal flood, there is more and more of confidence in these. And in the open ocean also, you can see that how the mean ocean temperature will be rising and how ocean salinity and dissolved oxygen will be reducing. So these are the climate impact drivers which are going to impact which are now almost understood by the scientists that how these are going to be impacting in future physical system. So based on that, what it shows is that, so basically although there is nonlinear relationship between the cumulative CO2 emissions and increase in global surface temperature, so it shows this historical trend, which is the thin black line, which is the median value. So these lines are showing the median values, and these colored shaded areas are showing there are many, many models which are running these surface temperature projections. So these are the median values. These lines are showing the median values, and these are showing the range of values which are produced by different models. And which it shows that this one is like all these are human caused surface temperature increase, right? So this does not include the natural, so it excludes, as I showed you earlier, that there is both natural cause and human cause. So these are only showing that how human cause are going to increase, because the natural cause is now can be modeled and now separated out, and we can only project the human induced temperature change. And what it shows here is that how the cumulative CO2 emission is going to increase till 2050. We are showing till 2050 because even if you will hear that there are talks about that many direct capture of carbon dioxide might be happening and all those issues, but anything that happens, physical impact of that by 2050 will not be traceable. So basically, what it is said is that till 2050, how much emission we are going to make will actually impact the global warming. So that's why we say every ton of CO2 emission adds to global warming at least till 2050. If you take out direct capture, if you reduce the emission from the greenhouse gases, you capture the greenhouse gases from atmosphere and then do something with it, either you bury it under the surface or you use it, whatever you do, its impact will be is not yet known. And even if anything happens, that will happen after 2050. So till 2050, you can see that whatever emission we do each day is going to add to the global warming. Now, I'm showing a little bit more on sea level rise because this is going to be important, because it is very important to understand that if the sea water warms up with this global warming, as we said, the temperature will be going up of the sea water, then its impact will remain for thousands of years. So that is most important. If you warm up the sea now, it will impact for next 1,000 years the sea level rise. So we can see that how sea level is rising already, that has been measured from the observed data. And then we see that this is unprecedented since last 3,000 years. And for Asia, we need to understand that Asia will be having the maximum population in the coming decades. And so the impacted population, so this shows what proportion of the global population will be impacted. So you can see that how Asia will have the maximum number of people impacted by the sea level rise. So these are the projections based on the different physical models and also the kind of other socioeconomic models which are running behind all these meta-analyses. So now the question is, sorry, I think if there is no background noise, that helps. If you are joining a session, you need to keep mute. So what this figure shows is that, so we understand that physical system till 2050 has been interfered with the human-induced greenhouse gas emission in such a way that 2050, the climate-induced drivers are going to impact the physical system a lot. And so how that is being positioned scientifically in the literature is that, so it says that climate change will cause impacts and create risks. So basically it will impact human society. And as the temperature rises, it is now very clear that at very high temperature rise, then there will be limit to adaptation also. And so now what we are doing is that we are saying that, okay, so up to a particular level of rise, there will be some adaptation possible for the human system as well as the ecosystem and biodiversity. But after a while, there will be a difficulty there will be limits to adaptation. So if that is so, then the question is, how does the human society plan their social activities and economic activities so that in future they reduce their risk? And so from risk framing, can we go to resilient framing development? We are saying now that our development and human system and ecosystem are at risk, but can we change this kind of activity that we are doing so that we can have a climate resilient development? That means where we have mitigated the climate change and we have adapted to climate change so that it makes the human system to change through its energy system change, industrial activity change, urban and rural infrastructure changes, and also the ecosystem protection happens, conservation, restoration of land, freshwater, coastal and ocean, and biodiversity happens so that the adaptation and mitigation make life more sustainable on Earth, and then both ecosystem health and planetary health are maintained. So this is how we are defining the climate resilient development. So in the scientific community now, there is a more research need and happening on what can be a climate resilient development pathway. How can human health and well-being, equity and justice can be delivered through development process, which will be resilient to climate change, which is not going to be risked to climate change. So we want to move out from this kind of developmental paradigm to this kind of development paradigm. So as you see, there is now more and more understanding that with the more emissions, so these are, as I said, are different socioeconomic scenarios or predictions, and these are also the different climate forcing. So if you look into these, then you see that as the temperature increases more and more, so this is more sustainable. Why we are saying sustainable, this is important to understand, right? So right now, by all observed data and estimates, all model estimates, it is seen that we are now at 1.09 degrees Celsius. So this dashed line shows that how much we have already warmed up. So it's not that global warming is going to be a future event. We are living in a warmer world of 1.09 degrees Celsius compared to the pre-industrial level of temperature, surface temperature. And so it says that as we increase our temperature above, so even if we are looking into the best possible socioeconomic pathway of 1.9 climate forcing, then still we will actually increase our temperature further, and which will be 1.5 degrees Celsius rise. With 1.5 degrees Celsius rise, with this, if you just think, then 1.5 degree rise also, you can see that some unique ecosystems, say for example, coral reefs, will be dying. So this color shows how high risk to these different systems are there. So these are called reasons for concern. So what is the reasons for concern in terms of adaptation is that there are many unique threatened systems which will actually no longer be existing when it is more warmer world. And extreme weather events are going to be very high, like very high temperature in summertime, very cold temperature in winter time. And distribution of impacts are going to be very different for different regions. And global average impact, we can see how this is going to be. And these dots are showing how confident science is in terms of say, for example, for each of these reasons for concern. And large-scale singular event is like, say, a ice sheet collapsing. So those will be the large-scale singular event, which will lead to, non-linear transformation of the ecosystem. So this is now clear that this is going to be, with a rising temperature, there is going to be high risk to different ecosystem services. And if you look into breakup more, then what will be the biodiversity loss, structural change, tree mortality, wildfire, how this will be increasing, carbon loss, warm water, corals, what will happen to them? You can see that they are going to die very fast, right? And it's already happening, that kelp forests in the ocean system, what happens, seagrass meadows, how resistant they are or how they will be. So you can see all these, what are the risks to these ecosystems. So this is almost now understood how they will be impacted. So basically the adaptation, how much adaptation is possible beyond 1.5 degree, it will be harder and harder for many of the systems, and many of the systems will actually just vanish. They will no longer exist with higher and higher temperature. So what is also important is that what is the impact on the human health system, right? So human systems, say, for example, heat-related morbidity and mortality, malaria, dengue, and so all these ozone-related mortality, how these are going to happen. So it shows that there can be either some societies, countries, or communities will be proactive in making adaptation from now itself and higher investment in health systems. So they will be in this safer zone, not safer zone, but with impacts, but at least adapted. But then there may be no investment in a health system in many of the countries or communities. So that will mean that you will be entering into the more non-adaptive zone, and so more risk to your health. So it is dependent that which kind of adaptation you are taking. Are you considering proactive adaptation, or you are in the incomplete adaptation zone, or you are in limited adaptation zone? So if we look into this, then from adaptation point of view, there is a very important a message which is coming up, is that there is rapidly narrowing window of opportunity to enable climate resilient development, which means we have already at the 1.09 warmer world, right? If we cross 1.5, which scientists are finding that in some of the years, in some of the areas, actually, we have already crossed 1.5 degrees Celsius, which means that and whatever I'm saying, so 1.09 is a global average temperature change, which I'm saying. But if you look into, say, for example, Himalayan high altitude region, the temperature rise is 4 degrees already experiencing, right? That's why glacial melt and all these we are seeing. So basically what it says is that how we can be in this resilient world. So these are the two predicted world scientists are envisioning. And we are saying that actually this we have already missed the opportunity. We cannot have a 100% climate resilient development. We have to adapt. We will have to face different losses to life, our infrastructure, our health, and etc. But then still, can we limit our temperature level to 1.5 degrees Celsius so that still there is some window of opportunity to have a climate resilient development? Otherwise, there will be more as we go more and more towards this path, which means that we will be reaching the adaptation limits and we will not be able to achieve the sustainable development anymore. So this is extremely important for all kind of social actors, we are saying, say, for example, investors, for policymakers, for professionals, for educators like us, to make this very clear that we have missed the opportunity of a 100% resilient, climate resilient world. And now we have to make rapid adaptation to at least make it with some losses and damages still possible to have a sustainable growth. But if we miss these opportunities, then we are definitely going to enter into a very high risk world where there will be so much of losses, non-linearities in the ecosystem and the human systems that it will be very difficult for equitable and sustainable development possible. So with this, I'm not scaring you all, but then what science is telling, we need to understand if we are trying to make our lives better in future for our generation and for the next generations to come. So what we are saying is that, so basically, so basically now, if we think how the real question is, how do we mitigate the climate change? That means what can be done to reduce the climate change by reducing the greenhouse gas emission? We have been talking about these issues for very, very long time. Then we see that still, if we see, then we see that global net human-induced anthropogenic greenhouse gas emissions between 1990 and 2019, if we look into, then we see that it is still increasing. And it is increasing at a quite high rate, right? So this is important to understand that how we are increasing. So over these almost 19, 20 years, we have increased from 40 gigaton to 60 gigaton. So that means we have added 20 gigaton more in the atmosphere of greenhouse gases. And if you look into the different type of gases that we have added, so these are the different types of gases that we have added. So now, this is important to understand that among these, the CO2 emission from fossil fuel burning and industry has the 64%. And then we have the methane emission and then net CO2 from land use change, and also nitrous oxide and fluorinated gases. And you can see that how fluorinated gases has actually increased at a very fast rate over these past 2 decades. So sometimes the question comes that who is contributing how much, right? Also need to remember that these greenhouse gases compared to our local air polluting gases like say SOx, sulfur dioxide or nitrous oxide, these greenhouse gases have very long life in the atmosphere. What we say is that if you emit 1 ton of CO2 today, it has a lifetime of 100 years minimum to stay in the atmosphere. So if we look into the total greenhouse gas that is existing now in the atmosphere, we can look into that, okay, so we need to go back. If we look into the CO2, then we need to think that over past 100 years, how much this CO2 has been emitted, and that is accumulating. It's like a bank account, right? We put each day money. So if we save more, it is good for us, we say. But then for CO2 emission, we are producing CO2 emission from all our economic activities, and it is going and residing in the atmosphere and accumulating in the atmosphere. So if you look into this time period of 1850 to 2090 and want to see that, okay, how much, who has produced how much? Of course, it has something to do with the developmental status reached by each country, because fossil fuel has been burnt more for the economic development. So you can see that well. So South Asia has contributed over this time period only 4%. And in Africa, 7%. So this is something, if you look into North America, Europe, then you can see that they have added 23%, 16%. So this is a kind of regional contribution in that. And that's what leads to the international political negotiation, who should reduce how much. And so this is actually that net anthropogenic GHG emission per capita for total population per region. So per capita, how much we are adding to the atmospheric pollution, that also has been estimated within the IPCC process. And these two very much, influence the political negotiation in the United Nations Framework Convention of Climate Change and the Conference of Parties. But one thing is very important. I said that historically, you can see that there has been cumulative emission from different countries. But as I said, the GHG emission accumulates and adds up in the atmosphere. So we have to go back 100 years to understand why today's carbon dioxide is so much in the atmosphere. But also, when we are projecting the future changes, we need to see that how over next 100 years, this will be created, right? So that you can make a policy that how we should develop in next 100 years, because in the past 100 years, we have developed in a way where it has created global warming. But we cannot continue this way, because we saw that there is more emission now in the atmosphere to which we cannot adapt. So we have to change it. So now the question is, if we look into, this is very important for countries in Asia to understand and for taking action for mitigation, is that this shows regionally. So Asia, MENA region. So these are the different regions. If you look into that, then you can see that what is the what is the infrastructure available in different countries, which can lead to producing more and more of greenhouse gas emissions. So it says future CO2 emission from existing and currently planned fossil fuel infrastructure in the context of Paris Agreement. Okay, up to this, if you just understand, then that will be enough. So which means that, so what is the infrastructure that we have from which we can, how these are projected, that what will be in future the emission, right? So if you look into your fossil fuel infrastructure in the world, regions, and you sum up them, and then you see that how much emission is going to be in future, then we see that Asia has the highest proportion of fossil fuel infrastructure for existing now, which means that over next century, over next many decades, the most emission will be coming from Asian region. Reason is understandable that these countries which have already developed, they do not need high rate of growth. For them, 1%, 2% rate of economic growth is enough to maintain their good standard of living. But for countries, poor countries, and with countries with a larger population, for them, for development of poor people and for not only for poor people, but sometimes also rich also get richer. And so for them, for Asia, we have more fossil fuel infrastructure, which is going to add to the next decades and till 2050 at least to the emission. So as I said, politically, who has committed more or contributed more to the greenhouse gas emissions so far, and who will be contributing more in coming years, is a big political dialogue which happens in the conference of parties. And that's how countries negotiate that who will be reducing how much and what kind of financial arrangement, because they have to make investment, new changes, and how that should be done. So these mitigation actions, based on the scientific understanding of the impact on the physical system and human system, these negotiations happen. So science, scientific knowledge production in all three domains of understanding the physical system change, adaptation, and mitigation is extremely important. And as from us, the academia, it is expected that how much knowledge we can generate through our research for helping making decision both in the local community and also within the national and the global context. So what we need to understand is that the market is also changing very much, right? Because there is new technologies which are coming up, say, for example, photovoltaics, onshore wind, offshore wind, concentrating solar power, just not the solar panels, but then concentrating solar panel, and then also batteries for passenger and electric vehicles. So these technologies are becoming, you can see how the market price has gone down. So they are becoming cheaper and cheaper every day. So this is showing that how each of these technologies are becoming cheaper in the market. And this shows how the market is responding to this cost reduction and how the market is growing in terms of adoption of solar photovoltaics and also onshore wind based power generation, offshore wind-based power generation, and also concentrating solar power, how this is increasing in different parts of the world, and also how the electric vehicle uptake is also increasing. But these are all global numbers, right? What we need is also to make these studies for our countries, that how these are getting taken up in our country. So that will give us a global picture compared to the national picture, and which is important for any policy making and for any action. So it says that, so basically what I tried to show is that globally many activities and actions are happening for mitigating climate change. But if we look into all these impacts, so every country have made some nationally determined contribution announcement that how much they will be reducing. So all those are voluntary pledges made by the countries based on their national understanding and circumstances. But it shows that, I mean, that cannot still limit below 2 degrees Celsius. We said earlier, we needed below 1.5 degrees Celsius, right? But all the pledges that have been made cannot lead even to 2 degrees Celsius. That will actually lead to 3 degrees Celsius rise, right? So the countries have taken action. They have pledged how much they will be taking till 2030, but that doesn't lead to, because we need to be here. And all policies currently make us follow this path, right? So how much emission will be happening. But if we want to come here, then we really need huge reduction in the emission. But that is, as I said, still emission is rising, so there is more important actions to be taken. So in the latest IPCC report, actually, it was projected from different models that, well, if we really go to the 2050, say the economic activities are done in such a way so that there is no carbon emission, then from different economic activity sectors, how much emission will be remaining. So if you imagine this 2019 bar, which shows that from which sector, say energy supply, right? So transport sector, from industry sector, from building sector, how much is emitted, right? So this is now what we are doing globally. So if we imagine different possible pathways, how alternative measures through which we can reach a zero carbon world, then by the mid-century, then there are different pathways which have been, so we call them illustrative pathways, they have been found, but which shows that basically how much from different sectors, here you look into the color, from how much different sectors they have to change. So from here, we have to change to either of these actions. But if you look into these pathways, what it means is that there has to be, so some pathways shows that you really need negative emission technology. That means you capture carbon from the atmosphere and put it under the surface of Earth, or you make your land to absorb more carbon. So basically negative emission technologies are shown here, but they are extremely expensive till date. And what will be the impact on the physical system, that is also very uncertain. But this green one is showing that, okay, how much is possible through just afforestation and reforestation, right? So that's something which is important to understand. So basically, this one shows technology intervention, negative emission technology, and this shows the forest-based and afforestation and reforestation-based negative emission technology, or they act as sink. So basically, it shows from different sector, activities need to be done in such a way, products needs to be produced and consumed in such a way so that there is less and less of emission. So this would mean how you change your fuel variety for producing your economic activity, right? So how you use electricity for your car, but that how that electricity can be produced by non-fossil fuel so that you can have no emission at the end. So basically what we are showing is that suppose how it can be done. This was a major contribution during this last IPCC report, which was published in 2022 and 23, that look at each sector. We need food and nutrition definitely to be served for people. We need manufacturing products, right? We do need land transport for mobility. We need shelter and buildings. Sorry, and we need electricity for providing different services in all these sectors. So if we look into these, it means for each sector, we now know how much decarbonization need to happen till 2050, okay? So this whole bar chart in every sector shows how much carbon dioxide reduction is necessary in each sector from activities. Now, if you think, say, for example, for each sector, then if you only look into the supply side activities, right? So how much, how can you supply the food by, say, renewable energy? I'm just giving an example, right? So then you are only looking at the supply side activity, then you need so much of decarbonization. But what we can do is that, say, for example, in the food and nutrition sector, this is very interesting because if you reduce your food waste loss, and then food waste and say agricultural produce loss in even on the farming lands, then actually you can reduce this decarbonization need to this. That means we reduce waste in the food and also in the production system. Food waste loss, if reduced, then we can reduce our carbon dioxide decarbonization need. That means we do not need so much of renewable energy, but we need only this much of supply needs to be decarbonized. Here also, in the manufacturing sector, we have seen that if we take, say, within the industry, efficient technologies, efficient motors, and all different kind of efficient technologies for production processes, and then if we can change our infrastructure, say recycling infrastructure, if we can build, and also maybe, we can change our behavior also. Say, for example, there is no need to change your mobile phone every year, right? You can make use of it. It's just for our fashion or to show others our status symbol that we change our mobile phones, right? But that's not needed. So if you reduce your demand for these products, and if you can use long life products, then also you can reduce your demand for a decarbonization, and the decarbonization in the industry will reduce this much. Similarly, for land transport, building sector, for electricity generation, we can see how you can change your appliances that you use, right? So you use efficient bulb, you use efficient refrigerator, you use efficient car. So like that, you can efficient building so that you can actually reduce your emission. Also, in electricity sector, what we are saying is that if you have more renewable, it is said that in the electricity supply sector, it is difficult to manage the load because maybe solar is very high during daytime, but then our demand is more in nighttime. So how do you manage this load, right? So, but then it's just not the air conditioning demand, but there are different kind of demands for electricity. So you can manage the load within a day. Intraday load shifting can happen, and that is something called load management or demand side shift can happen. And all these can add to a need for reduction in in electricity sector decarbonization. Right now, all countries are saying that we need more of solar, more of wind, and like that, but then that is impossible to get for the whole world because there will be material will not be available for production of solar and the wind energy. So we have to reduce that demand. How do you do that? By changing your appliances and by making your infrastructure different. You make more public infrastructure better, say air-conditioned buses. Then you will not take every day your car out, but then you can go by the public transport to your office, and but still with the same level of comfort and well-being. So basically what we are saying is that there are multiple ways how you can reduce and still economically you can grow and create jobs, and still you can manage your human well-being without committing more greenhouse gas emission in the atmosphere. So with all this knowledge which we already have, we have shown that it is actually possible to manage 1.5 degrees Celsius rise in this whole century. We can stabilize, but we see that the countries are not on track. And the UNEP report shows that basically whatever policies are existing, we will be here, whereas we need to be here. And then also, if you look into different more pledges which have been made by the countries, still we are much shorter than what we need. So if we see into the nationally determined contribution we have seen, then emission will be less by only 1%, but we want to reduce it by 45%. So you can understand that how different economic activities need to be conducted around the world. If we do not do that, what might happen? So scientists are also trying to see that, okay, we may not be able to do it in next 5 years. So if we can't do that, then what happens to the temperature, right? So it shows that, so because of the nonlinearity, what will happen is that maybe the temperature will overshoot in the near term, and it might go up to, say, 2 degree or 3 degree at some point of time. But still, if you try to mitigate now, after a while, it might be possible to stabilize again by the end of the century. So this tipping point is becoming very important discussion now, because if we are really not managing or mitigating our greenhouse gases, then we will be entering into the danger zone of reasons for concern in those burning ember diagram, where I showed that there is going to be less adaptation possible. So ecosystem losses, human system losses will happen. So this is a very worrisome situation. Scientists are now trying to understand more and more what happens if we are overshooting the 1.5 degrees Celsius goal. Because all the political dialogue gets buried under the fact that, because, it is true, whatever we have extracted from under the ground in terms of coal, oil, and gas globally is only this much of amount. But still, you can see 2/3 of that is still under the ground. So globally, we have to take a decision collectively that whether we should leave gas, coal, and oil, say maybe for 50 or 100 years under the ground, and we use other sources, and maybe these can come back after 100 years again for use when we have stabilized the temperature, and when we might have other kind of technologies which can produce from coal power, but without any emission, which is also possible, right? So basically what we are saying is that, so within over what time period, what kind of decision world has to take is extremely important. Because if we continue as we are going, as we said, then we will be in this scenario, which will mean that we have to take out. This yellow color shows how much of carbon dioxide we will have to take out from 2030. And globally, we do not have that much of technology. We don't have that much of money to do that. So this is an impossible task, and which will mean that burden of adaptation will lead to a situation where we will reach the limits to adaptation. If we look into this scenario, which scientifically possible, given all the technologies globally we have, that we can actually take the demand side measures along with supply side measures, as I showed, then by the turn of the century, what we will need is that from the mid-century, what we'll need is that more of reforestation and afforestation, which is a known technology for sink creation, and then we will be able to stabilize by the turn of the century. But there may be some overshoot, as I already said, because we have not been doing well over last 20 years, so we have put in more greenhouse gases, so very likely that a world will overshoot. So in that case, what will happen, that scientific knowledge is getting built up, and that's a very hot area of research now. So globally, all the countries have to decide whether they want a dangerous zone to enter for future generation, or they want to be in a more comfortable world where they can use all different kind of technologies and behavioral changes so that they can have better life now as well as in future for the future generation. So what we are saying is that very important research question is that now we know consumption of bottom 90% of people is only 48% of emission causing, right? But if we look into the top 10%, then 37% of emission is being created. And top 1%, in every country we have, in our country also we have, right? So top 1% of consumers emit 15%. So you can see who is using atmosphere to whose benefit. So basically, this is a question of equity and then social justice. So I think citizens, investor, consumer, professionals, and also say role models. By that we are saying that maybe high consuming individuals, they can become role model by reducing their consumption and investing in decarbonization of the world. So basically what we are saying is that there is need for equity and justice in the whole action and collective action to tilt the balance towards dignified, sustainable, stabilized temperature and away from global warming. And just to, so this is a major message that we could give from the IPCC report, and this chapter I was leading, and then we could, I'll just share with you now some of the examples from India, because sometimes it comes in our mind that, is India really doing? People say that India is not doing anything. Some people say that no, I mean, science shows that India is also doing a lot, right? So if you look, the Indian industries had been the leader, right? So when I was in Jadavpur, we did this research and we could show that actually in India, if you look into the 70s and 80s decades, for each product energy. But now our technologies are so efficient that we need much less energy. And so our energy per unit of output production has gone down, and we use efficient technologies. The industries have been using that. And then that's how we have decoupled our activity growth from energy growth. And basically, we can see that different industries, right? Textile, pulp and paper, steel industries, chemicals, cement, aluminum, they all have spent money and they have taken measures to reduce their emission. And how much money they have spent, if you see, then we are saying that they have spent actually from $20 per ton of carbon to even $100 per ton of carbon for making the Indian industries much better. So remember that India has been contributing, and we have made this analysis, and this actually shows up in the 2017 IPCC report, and which shows that how Indian industries are taking leadership. We also show that if you look into the Indian agriculture, actually we have been able to reduce our methane emission, but then our nitrous oxide emission is actually increasing, and which is important. This is because of the fertilizer use and disproportionate fertilizer use that also we found. And this happens because of the price of fertilizer, the way it is maintained. It's a wrong signal in the market, and so more N2O is used in the so in NPK, the farmers are not using the prescribed scientific formulation, but they use more nitrous oxide because that leads to faster growth of crops, and that is because of the fertilizer price. So what we are saying is that in the energy sector, there is really important that how we move away our thoughts from just energy carriers, how much of coal, how much of oil, gas we need. So from this, how we can move towards how we can get the access to mobility, how we can get access to electricity. So accessibility, availability, and acceptability are now the guiding principle for energy sector. And what we have done is that we tried to develop an Indian zero carbon energy pathway, and we have included, and we just made an assessment whether just by onshore, offshore wind and the PV of different kinds of photovoltaic technologies, can we meet India's growing demand, say by 2050, even if 5 times demand is increased. And we have actually done very spatial scale model, very detailed model, and we saw that for India, the best thing is that we have resource availability complementarity, by which we are saying that during daytime when we have solar, then wind is low. But at nighttime and in early morning time, wind is more and solar is less. So basically by solar and wind complementarity makes it possible for India to plan even 100% renewable. And we developed many scenarios to look into the costs. So our results show that if we think in terms of reliable solar and wind-based systems, we can include demand-side flexibility, storage technology. We can produce electricity in India at 3 to 4 cents per kilowatt hour, which is cheaper compared to our current production cost of 5 cents per kilowatt hour. But what it means is that we need to take actions from now, plan it in such a way so that we include all these different strategies and think in terms of our transmission distribution lines, generation capacities, and investment decisions. We also did for West Bengal and wanted to see, given the solar potential, what is possible. And then also we saw that basically, if we can make an investment in different phases over next 20 years, which will be 1.03% of the state GDP, state domestic product, then we can actually make by 2040 a more zero carbon generation for West Bengal also, which will mean how much of storage technology needed, how much of solar, how much of bio, how much of demand side shift, that means intraday load shifting, all these are needed. We have estimated, and we have estimated also how much investment will be needed. So with all these, what we are saying is that basically there are possibilities. So science knows that what can be done, but that has to be implemented by the policymakers, by the citizens, and by the investors, and consumers also need to be conscious about this. And with this only we can achieve the goal and keep our planet safe. So with these words, I'll be stopping here. And if you have any questions or anything, you can ask me. I would request Dr. Mondal to, moderate this if there are any questions.
Please 2 minutes चुप लेना. Thank you so much, ma'am. Is there any question, participants? If anybody has any question, kindly ask. So, ma'am, we sincerely thank you for your enlightening lecture on the current status of climate and change prediction. It was really, really helpful and expertising for us. Thank you, ma'am.
Thank you very much.
Thank you so much, ma'am.